Fantastic. We have an inventory. We can swap around slots. We can move around slots. We can split up stacks as much as we like. But the one thing that we cannot do yet is merge those stacks back together. And that is quite an important bit to get right here. So let's get into that today because there's quite a bit to this. We have a lot of edge cases. We have merging things together with a left click. We have merging things together with a split right click. We have to build in things to prevent it from going over the max stack size, and there's just a lot to worry about here and a lot of edge cases to program in. So let's get started with that. We're gonna open up our inventory component because we need to do some stuff in that. And then we're also going to open up our item slots. Now, first things first, we're going to add a new function to our inventory component that is going to allow the merging of two item slots. So let's make a function for that and call it merge stacks. And that's going to have a couple of inputs. Of course, it's going to have the two slots that we're going to be merging. So that will be the source slot and the target slot, both of which will obviously be a inventory slot structure. So inventory slot structure, there we go. But then since we're also going to have to deal with left click and right click separately, we can make this into two different functions if we really wanted to. I personally prefer it to all be inside this one function so that we can just throw it into other UI elements and it will just work. So for that, we're also going to add a third parameter, and that will be our pointer event. And that will be of type, you would be surprised to learn, a pointer event. And this is just going to carry whether or not we're using the left mouse or the right mouse operation. But we'll only do that at the very end. We'll just make the left mouse version first, because aside from that, it's just a lot of copying work to begin with. So we'll add in a branching node here, and we'll get from that the affecting button, and we'll just check whether or not that is equal to the left mouse button, and we'll get back to this branch at some point in the near future. The next thing we're going to do is add another branch a little whiles away, just to make sure that we have enough room. And this is going to decide whether or not we want to just merge two stacks together, or whether or not we do a little bit extra trickery in math because two stacks don't fit on each other. So let's take a look at that. We can get our source slot and break that apart. And then we also get our target slot and also break that apart to get all of the internal information for both of them. If we want to get our source slot stack size, and we add that to the stack size of our destination slot, so the amount of items that are already in there, the output from this is not allowed to be larger than the max stack size of any given item. We have an item asset, we can take it from either one of these because they're always going to be the same item. We're checking that beforehand anyway. So I'm going to take the top one in this case, and we'll get the maximum stack size. And here we can simply check whether or not that addition operation results in something that is less than or equal to that stack size. Let's move that over here to where it belongs. If these two things added together are less than or equal to the max stack size, we can simply just add them together, and that's the simple bit. Because we can just take our inventory array here and we can say set element, break open this structure pin just so that we have all of the pins separate from each other. Connect it up to the true, and then we just want to set the array element for the target slot, the thing that we're going to be putting things into, the index taken from that, and we can just add a rerouting node here because that's also going to go into the item index. Then the stack size is simply going to be the output from this little thing over here, because it's going to be our source plus our destination is going to be set to our destination. The item type we can simply copy over from one of the inputs. Doesn't really matter which one you pick for this one. And the same with our has item. This also can just be set to true, to be fair, because it's always going to be true when we're merging things together. But I just like to connect up variables just to make sure, and it feels nice, right? It just feels nice. Then though, we have added something to our target slot, but we haven't removed anything yet from the source slot that we've been taken from. So what we'll do is we'll copy over the set array element. Of course, we'll be working with the same array here. But now instead of taking the indexes from the target slot, we'll be taking the indexes from the source slot instead. So we want to set up the index here and the item index from the source slot. And then we want to just make this one entirely empty. So has item is going to be false, item stack is 0, and the item asset will be set to just a null pointer, like this. That way it actually removes those items from the slot that we've taken them from. And once we have done that, we can simply call on inventory changed so that the inventory visually updates as well. Now, the next part is the left click version, which is still what we're working with here, of what if this is false? What if I'm trying to add something to a stack that doesn't allow for that much more room? So, for instance, our stack size for the rocks at the moment is 64. What if I already have 50 items in that stack and I'm trying to add another 20? That would add 70, and that goes over the maximum stack size. So we need to implement something for that as well. Now, we're going to be using another one of these set array elements, of course. I'm just going to copy over the node that references the inventory. And naturally, just as we were before, we're going to use the target slot for the index because we're setting the target first. The item slot can just be copied over from either one of these nodes. Again, it doesn't matter. The has item slot, again, same, or you can just set it to being true, whatever works for you. But the item stack size is actually remarkably easier, because the entire point of the setup that we're making here is what we're trying to add is going to overload the stack size. So the stack size is always going to be maximum, and we already have a reference to whatever the maximum stack size is allowed to be for this specific item. So we can just put that into the set array element and we'll be fine. This is the easy bit, but now we need to calculate how much over that stack size limit we go and put those items back in the stack that they originally came from. Because if you're trying to add 20 to a stack that already has 50 and it's getting set to 64, there's 6 items remaining left over. That what are we going to do with those 6 items? And those 6 items need to go back from the stack that they were originally taken from. So the way we're going to do that is using the add item to stack function that we made in a previous video. The stack index that we're going to be adding them to is going to be our source slot. So the top one in this case here, the thing that we've been taken from, that's what we're going to add them back into. So that will be the index that we're adding to. The amount to add is a little bit more tricky to calculate. Not that much though, don't worry. Because what do we have? We have the maximum stack size and we have the amount that our 2 slots will be added together. If we take the outcome from this addition operation and from that we subtract the maximum stack size, we now have information about how much overboard we are going. So again, if this ends up being 70 and our maximum stack size is 64, the outcome from this little subtraction here will be 6. And we can just set that to being a local variable, so we have a place to save it. We'll just call that remainder. And that way we have a variable that we can access whatever the remainder should be, even if we set this array element. Because at that point, all the calculations using these inputs are going to change as well. So it's a good thing to put this into a separate variable that we can access even after we change the array element, because we need to use it here. And the amount to add will be our remainder, because we're adding back that remainder to the original slot that it came from. But now we have a similar issue as to what we had here. And that is that we are now adding the remainder back into the original slot without taking anything out of the original slot. And that's kind of due to how we have the left click functionality set up. We're not removing anything with our left click and drag the moment we start our left click and drag operation, like we are with the right click and drag operation, because we also need to have some functionality for swapping these slots. So it doesn't really work that well with it. And that's why we're making 2 different implementations for either left click or right click. Right click we'll get to in a minute. But this means that we still have to subtract the amount that we have added to our new slots from our original slots. And of course, that's actually quite easy, because what we can do is we can just take this stack size over here and we can multiply that by -1 to make it negative, because it needs to be negative. And then if we just add the remainder to that, this will now be the proper new amount. So we are subtracting the amount from the original stack that we're trying to move, but then we're adding back in the remainder for the amount of items that didn't fit in that slot. Doing that together and using our add item to stack function like that will mean that we now can left click merge things together. And of course that also needs to hook up to call on inventory changed. Now this is the left click version of the entire thing, and it looks like a mess, but that's just because we're going through this tutorial and just willy-nilly hooking things up. If you're looking into the actual project files that I'm going to be including, maybe not the episode by episode project files, but definitely the finished project files for the entire series, everything will be ordered a little bit more neatly and more readable. And if you want to check out those project files, you can do so in the links down below in the description to the Patreon or for YouTube members. All that self-promo out of the way, let's add in the right-click version. So we can also go off of the false pin here, and that we'll just assume is right-click. And what we'll do there is we'll just copy pretty much all that we have here, and we'll paste it down here, which is less than ideal, but that's just the easiest way to get all the information that we need to have. So we need to reconnect up a couple of things, that being the max stack size for the items can be taken from either one. And we need to take the stack size from both of these and connect that up to this math node that we have down here. Both of these indexes should be the destination slot. So that's the bottom one down here, or the target slot as I called it. So hook that up into that index and this one as well. And then both of these need a reference to the inventory array too. So just need to hook up a couple of things that I didn't properly select is really what it comes down to. The item asset and the has item for this one, also copy those over from the destination or the source. In this case, it doesn't really matter. And then this one also is an index that needs to go into the destination slot index. Don't forget to hook up the item has item to something when you're copying this over, because I did. And that made me really confused. And also the item asset itself. Don't forget to hook that up. Somehow I entirely blanked on that. And that's really why you don't want to have a blueprint like this, because it's very easy to miss out on things. And I believe with that we're pretty much there, because the only real difference between the top one here and the bottom one here is that in the bottom one, if we're doing any right-click operations, we don't need to subtract from the original slot, because that's just baked into the way our right-click operation works to begin with. Now, you could make an argument for maybe you shouldn't have done that, and you should just make it streamlined between left-click and right-click. Personally, don't think this is that big a deal, and I really do like the fact that when you right-click and drag to split a stack, it immediately shows you the new number on the old stack. So that's kind of the reason we're doing that. But we don't need to do any of this math down here with the bottom add item to stack. That's just going to be the remainder is going to be the amount to add, and the item stack index will still be the source slot. So that will be the index from the top one here. And for the right click, you also don't need to do the true path, the second set element, you don't need to do either, because this is to blank out the original slot. And of course, we don't need to do that because that's already dealt with by our right click operation. So we can delete that one as well and immediately go into call on inventory changed. And of course, we need to hook up these two branch nodes. So the branch node for left mouse button, if it is false, it's going into the input for this branch node over here, if I don't mess it up. And once again, this looked like a entire mess. We'll make sure that things are a little bit more cleaned up in the actual project files that we will be providing for extra material. So this is the function for merge slots. And this was mostly the painful part of today's video. So let's go into the WBP item slot and actually implement that, shall we? Because last time when we left off here, just to refresh our memory real quick, we just said, hey, if the slot already has an item, just do the add item to stack, which is a function that will put back those items in the stack that they came from. But now we're going to add another if statement to this, or a branch, if you will. And here we're going to check, hey, there is an item here, that's neat. But if that item is actually the same item between the destination and the source, maybe we'll try to merge them first. So if this condition is false, we'll still do the add item to stack. And if it is true, we will use the inventory component to run a merge stacks function. And we'll plug in those parameters in a minute. But first, let's do the conditional check here. We have our inventory stack, which we get from our drag drop operation, in case you have forgotten. And from that, we can just get our item assets, and we can just say equal as a condition check. And we're going to check that against our own inventory slots, which we already have an easy to get reference to here, actually. Just to see if it's the same item. And if it is, we run the merge stacks. It's just as easy as that. Now, we want to pass through, first and foremost, the pointer event, which we can get if we just go all the way back here. The on drop has a input for pointer event. We can just pass that through easily like that. And then the source slot and the target slot. The target slot is just going to be our inventory slot that we're working on right now. And the source slot will be our inventory stack. Again, the thing that we're getting from our drag and drop operation. This will only do the merging though for the right click version of moving items around. Left clicking still doesn't have any merging. So you can really decide that if you don't want to have the capability of right click merging or the capability of left click merging, to just not include either one of those. I don't see why you wouldn't do that. But this is also why we made a single function that inside the function just has capabilities for both left or right clicking to merge. You can also make those into separate functions. Just put the right click version here, and then we're going to be adding the left click version up there. So let's take a look at that. We can just copy over pretty much these same conditional checks up here. And we'll just first and foremost check, add in one more branch now, actually. First and foremost, we will check whether or not the slot already has an item in it, which we can do with our target slot has item. Let's just copy this over here just to make this a little easier to work with. We get that off of the inventory stack from our drag and drop. And let's check whether or not this thing has an item. If it doesn't have an item, we'll just run the swap slots function, which is what we've been doing so far. If it does have an item, we're going to check, hey, is there a possibility for merging this? If there's no possibility for merging it, we're still just going to swap the slots. And the way we check for the possibility for mergers, we've done that now a million times. We check this item asset, and then we also get our inventory slot. We split that structure pin and check that item asset as well. And if those are the same, we once again do the same thing. We run the merge stack function off of our inventory components. So we merge stacks. Pointer event, of course, takes information from the input on the onDrop function. And then we do much of the same way. The inventory stack that we pull through is going to be our source slot, and our target slot will just be inventory slot that we have on here. Now, there's one important thing that we need to actually update in order for this to work. And for that, we're going to go back to onDragDetected. Because as you can see, on the right-click drag, we send through a inventory stack in the creation of the drag-drop operation that we have here. But we don't really do that at the moment with the left-click version. So what we'll do is we'll just put the inventory slot into there. We haven't been using that information up until now, so I haven't connected it up. But right now we're going to be using it, so it is important to have. And that is basically the setup for merging stacks. So let's see if it works. For ease of testing, I'm going to go into my item assets here, and I'm going to go rock maximum stack size like 10, because otherwise getting to 64 is going to take a while. It's going to be annoying. Don't really want to do that. And for this quote-unquote chest that I have here, I'm also going to go in and set the stack size for the rocks that spawn in to something like 20 for both of them. I could just spawn in one with 40. I could. Probably should. Let's test this out. And now we can like just pick up the sword, because why not, and then pick up a unhealthy amount of rocks with all my line tracers, and this should really be enough for me to be testing my inventory with. So let's open the inventory, test out. We can still swap around our slots. We can still move to empty slots because that's functioning the exact same way. We can still split stacks like this, but now what we can also do is we can pull a stack onto another stack and it will merge them together, which is very nice. And that just added 5 and 5 to 10, that's a full stack. But if I take this 3 stack over here and put it on this 5, it becomes an 8 stack, which is fantastic. Now, if I pull half of this 8 stack off and put it onto this 5 stack, this will become a 9 stack, even better. Now, if I put this 4 stack and I put it onto the 9, it should become a 10, and this should become a 3. And so it does. So now the last thing that we need to check is if we merge this all together, that's fine, an 8 stack. If we try to like go overboard with a split stack like this, so we take 5 out of here, we try to add it to this one, this should be 10, and this should go back to being 8. And so it does. So our inventory splitting and merging now fully works. There's a little bit of iffiness in some of the setup here because of the way we have some of the other code set up. Again, I really do like the idea that when you pull off of this, you immediately see that there's 5 left here. And it's kind of just because of the way we have that set up that left-clicking and right-clicking operations are dealt with differently. But now that we have all of that set up, we shouldn't really have to think about that anymore, because we can just use these functions in a bunch of different scenarios now. And that's the basics of the inventory itself done. The only things that we really can do now is go forward and add things like dropping items, maybe add things like chests and shops. And we'll do a couple extra parts here to implement those slightly more advanced things, but this is the basic setup for your inventory system. And for the full course, if you're watching this in the future, it should be all up on the YouTube channel already. But if you're watching this shortly after it was uploaded, there will be a link down below in the description to the Patreon where you can find the full course, plus a little bonus episode where we go over and change some things to make some alternative ways to interact with the inventory, which will be a Patreon exclusive episode. And a very big thank you to all of my Patreons. You can see them on screen right now. If you want to help out supporting the channel, there's a link down below in the description to the Patreon page. And a special thanks to my Cave Digger tier Patreons, Sir J. Thomas,